Find the limit as x approaches negative 3 of this function. We have radical x plus 4, all of that minus 1, divided by x plus 3. All right, so the first thing we want to do is, usually, right, just plug in the negative 3. Hopefully we get a number, because if that was the case, then that would be the answer, right? So let's go ahead and try that. Let's plug in the negative 3. So we get radical negative 3 plus 4 minus 1 all over negative 3 plus 3. And we can see immediately right away we're going to run into some problems, right? We get 1 minus 1 on the numerator, which is 0. We get negative 3 plus 3 on the denominator, which is also 0. Okay. So does that mean that this limit does not exist? Okay, well, it does not. Okay. Now, remember, that means that the function value, right, at negative 3, this function does not exist. Okay, but that does not necessarily mean that the limit does not exist. So, what can we do with this guy here? Well, we notice that there is a radical in the numerator. Okay, not in the denominator, right? But we can actually rationalize the numerator here. So what does that mean? We're going to multiply this by radical x plus 4 plus 1. And we'll multiply the denominator also by radical x plus 4 plus 1. Okay, and let's put some parentheses around these guys just to make sure that we do multiply these properly. Okay, now in the denominator, I'm just going to leave it in parentheses, so I'm not going to actually follow these guys out. So I got the x plus 3 here, I got the radical x plus 4 plus 1. Now in the numerator, check out what happens. Right, we have a difference of 2 squares. Right, so we're multiplying this binomial times this binomial. So I know that when I FOIL these together, right, when I FOIL these two guys together, the outer and inner terms will cancel out. So I just need to multiply the first terms, and then in this case, minus the last two terms, right? So radical x times radical x plus 4 times radical x plus 4, well, that's just x plus 4. And then, well, I don't need to do the outer and inner terms. Negative 1 times 1 is just negative 1, right? Well, look at that. That just gives me x plus 3 on the numerator. And wait a minute. I also have an x plus 3 in the denominator, right? So those are just going to cancel out. Okay? So those do cancel out. So what are we left with? We are left with the limit as x approaches negative 3. Now, you notice I didn't write the limit at each step here. You could if you want to, but remember that here we're just doing some algebra. Technically, we should write it at each step. But we are finding the limit as x approaches negative 3 now of this function 1 over radical x plus 4 plus 1. Wait a minute, what happens when I plug in the negative 3 here? All right, when I plug in the negative 3, I get, well, negative 3 plus 4 plus 1 here. So, hey, wait a minute, I get 1 plus 1, so I get 1/2. So the limit of this function as x approaches negative 3 is 1/2. Now, I do want to remind you that doesn't mean that the function value, right, is 1/2. Okay? Because as we've determined, when we plug in a negative 3, that value does not exist, right? But this is talking about the limit. So if you sketch this graph and you checked out what happens as x approaches negative 3, we would see that the y values get closer and closer to 1/2.